Okay, so today we are going to do again the last part of the Trigo 3D problems. Now in the diagram, you may see that it is a two-dimensional. Okay, it may look like a two-dimensional, but looking at the story here, it says that this is a horizontal ground, and this is actually a building, TA. So how does it look like in 3D? Okay, so this is how the diagram looks like, right? Actually, this is folded up 90 degrees, and hence actually the picture is this way. Now, what does that mean? Okay, what it means that because this is on the ground and then this is vertically up, you cannot just add up the angles. All right, you cannot just add up because this is on the ground and this is not on the ground. This is actually jotting up like that. Okay, very good question. It's a wonderful question. Now, this is 90 here. This is 130. Why is it not 180? Now, the reason is like what I just explained. This is on the floor. This is coming out 3D. So these two angles are not side by side. This is on the floor. This is coming out. So it's not side by side. So the wonderful question is, why is it not 180? Because they are not side by side. So this is a 3D diagram. Now you must imagine it as a 3D. But in terms of the formula, there's no new formula. We'll still use the one that we have been using. So let's do a quick recap. What is the first formula that you will always try? You will always try Picasso to find length and angles for right angle triangle. Now the second one you try is Pythagoras theorem. This is very limited. Only for right angle triangle, only for length. Now the third one. Okay, now we have a bit of problem now. Since the two easy questions are out, the third one will be your sine rule. Do you remember the formula? Yes. Okay, that I don't write down here first. Okay, the last one will be your cosine rule. These two formulas are given during your WA. So let's look at what four parts they want to ask. Now the first question they want you to find is BC. Which formula are we going to apply? Is it a right angle triangle? Yes. Is it BC part of a right angle triangle? Yes. So you are saying this is a right angle? No. Is this a right angle? No. No. So what is the value of this angle? You minus by 130. So our answer is 50. So we call this angle X. Every time you don't want to label A, B, C, E, F, G, you just write X, and then you can do this during exam. Write X equals to 180 minus 130. I will go and look for your X equals to 50. All right, Jinan? Okay, the next part is what formula are we going to apply in order to find BC? Okay, this one you must tell me, your WA coming, which formula are we going to use? Okay, I will draw it out here so that you can see even clearer. Now, this angle here is 50, this is 125, and this is 178. I want to find this length here, BC. Can you all see already which formula? Yes. Okay, so it is cosine rule. So cosine rule states that A square equals to B square plus C square minus 2BC cosine A. Okay, just a show of hand. Anyone wants me to write down the formula for you? Okay, so the formula goes like that. Okay, let me write in red. Okay, the formula is A square equals to B square plus C square is given during your WAs. Cosine A. Okay, so Y square is 18704. Now, can someone tell me what's wrong with this number? Yeah, I did not square root. So I need to square root. Okay, 0.95. So I need to square root this, and that will give me BC. All right? Okay. Now, if you forget what you're finding, Jinan, okay, please write this down. Now, part B here, find the height of TA. One important thing to note, every time you found a length, please write down the values. Okay, for TA, the question is, which formula am I going to use? Which one? Before I draw the diagram to show you, what do you think I'm going to use to find TA? Which formula? You must say which formula? Wow, very good. Tuakaso, okay, I draw out the diagram for you now. So for the diagram I'm going to use, it is a right angle triangle. So this is A, T, and B. Because I have the angle 23 and the length 178, I can use Tuakaso. Do you realize that it's actually, I want here, so this is your opposite, and then this is adjacent, so I'll be using Tua. Very good. So Tua is your tangent, theta equals to opposite over adjacent. So your, any angle given?
33.
Okay, Azwan, what's your opposite? What's your opposite? It is your TA. Now it's okay to write opposite, but at the end later we will just label as TA. So adjacent, 178. Can you tell me now the last step? Do I cross multiply or do I flip? This one you again must tell me. Am I going to cross multiply or am I going to flip? Okay, now TA is on top. All you need to do is just cross multiply. Just cross up. Okay, and you get the answer. You only flip when TA is at the bottom. Because TA is at the top, we will just cross multiply. Answer is 75.557. Okay, so later you try this. There's another question for you. Okay, now this is just a revision. Let's do something new today, part C and part D. Where is the shortest distance from A to BC? Okay, before we do that, let's label the TA since I found it. TA is 75.557. So the shortest distance from A to BC. Okay, the concept is like that. I have a line BC, right? And I have a point A. Where is the shortest distance? Yeah, I draw it down. What do you mean by draw it down? Wait, what do you mean by draw it down? There's something very special about this black line. Very, very special. It is a perpendicular line. The shortest distance is the perpendicular line. So I need to find the perpendicular distance from A to BC. Okay, I'm going to draw the diagram one more time for you. Okay, I hope it makes it easier. So the diagram looks like this. I'm using the triangle ACB. Okay, so the triangle is like that. And I am asked to find the shortest distance from A to BC, which means I need to have some length. Okay, I have here 178. Okay, here 125. And I have here 136.766. How do I find the length H? How come we can do that? Because we know that this is 50 degrees. So we'll use the formula area half AB sine C. That's the area, right? Is equals to half times base times height. Okay, I'm going to show you how to do it. Don't worry if you are not clear because it's the first time we are doing it. Okay, now, can you all just tell me what numbers to put in? Okay? Minimally, just tell me what numbers to put in. Half times, I must use 178 and 125 sine. Irfan, sine what? Yes. Okay, so that's the area of the triangle. Now I use the same triangle, but I have a different formula. Half times, what's the base length? Okay, this is the base. Okay, so I draw this in red. I'm using the red one. 136.766, and I can find the height. Yeah, it's on. That is my worst nightmare. Okay, so this is a number. This is just a number, right? So don't worry. And I use this times this. Why? So how do I find H? I take the blue color and I divide by the red color. So finally your height, which is the shortest distance, is 124.6. The blue color comes from half times 178 times 125 times sine 50. Yeah, I'm doing the area twice. Okay, in order to find the height. Because this area and this area must be the same. So I use half AB sine C to find this area. So half AB sine C, I can find this area. Now, another way to find area is half times base times height. So half times base times the perpendicular height. Please do not divide this by 2. Don't get divide by 2. This is the best way. Don't get divide by 2 and then assume this is 25. Salah. It's not. So just take note. Use the area formula. Okay, the last thing, something new. I want the greatest angle of elevation of T from a point on BC. Now, when do you have the greatest angle of elevation? So, is it greatest angle of elevation, is it near or is it far? So, the greatest of angle of elevation, you have it when you are the nearest. You will imagine as you are looking at the clock in the class, right, or the flag, you are looking at the clock this way, right? As you go nearer, your head is going to tilt higher. So, the nearer you are, the greater the angle of elevation. So, I want to go as near as I can. As near as I can. So, on BC, the nearest I can go to the point here is down here. Shortest distance. Again, I'm walking along this. And I'm looking up at here. So I'm looking up, I'm looking up, I'm looking up, I'm looking up, I'm looking up. So at this point here, I am tilting my head the highest. So I will draw a 2D diagram for you. X, A. So this is X, This is A. Okay, again this X. This is A, and I'm looking at T. Okay, very simple only. I want the greatest angle of elevation here. This is the angle I want. So all you need to do is tell me what are the measurements. What is the length of TA? Look at the picture. What's the length of TA? Or look at the question so far. It's there already, all there already. What's the length of TA? 75.557. What is the shortest distance? XA. What is the shortest distance? Is this actually here? This is H, right? So the shortest distance is actually 124.6. Okay, last part ready for today. How do I find the angle theta? What formula? I will use Tuocaso. Okay, why? I have to find the angle theta. I'm given the opposite. The opposite is actually the TA over the adjacent, which is your shortest distance. Again, 124.6, that's the important part, is the shortest distance. And hence, okay, so the greatest angle of elevation is 31.2. Alright, can we stop the video? Okay, now let's clarify. Okay.